So my last configuration resulted with multi-area OSPF in which I have the backbone area. It's always area 0. It is backbone area. And that area 0 is significant here because it needs to connect all other areas. So in order for the traffic to go from area 4, which is physically connected to the area 0, it has to be through ABR. In order for the traffic to go to area 5, it needs to go through area 0, through the backbone area. That's how OSPF is designed hierarchically. So the ABR role is to connect area 0, the backbone area, to some other area. And sometimes in real life, we have this task of preventing maybe a router from learning certain networks, either for security reasons, or maybe we do some maintenance and we need to stop the traffic going towards certain network, and so on and so forth. How do we do that? So I'll just have an example here. So in OSPF, obviously it's a bit more complicated because we cannot stop R1 from learning, for example, network 10.1.45 0/0 advertised by R4, R5 here, because the link state database within the area must be the same, must be synchronized. It has to look exactly the same on all routers here in this particular area. The same would be here, but I have more networks here available. So how do I do that? I cannot stop, let's say, R1 from learning subnet 10.1.45.0, but I can stop R1 from installing this into its routing information base, a routing table. How do I do that? So at the moment, I have show IP route OSPF. Let's go for OSPF here first. And I see that one installed in the routing information base. So the 10.145/24 is actually available here via 2 paths. So if, and obviously I can stop this from entering the routing information base, but I cannot stop this from entering the link state database. So it has to be there. So if I have a show IP OSPF database first, maybe. If I see netlink states, okay, there it is. So I will have that network advertised by DR in that subnet, obviously. That link is advertised, but I can stop this from being installed into the routing table in OSPF. So I can filter OSPF prefixes only from being installed into the routing table, but not from entering the link state database, which obviously is the little restrictions we have in OSPF. We don't have that restrictions in EIGRP, for example. So how do I do that? So it's going to be there's a command in the routing process, and the command is distribute list. Now, distribute list command takes arguments, and those arguments can be access control list, standard or extended. This is expanded numbers, same thing, standard or extended. We can use named access control list, and we can use prefix or route map. So now the information about access control is you'll find in the description box, but maybe at some point I will record a video. But access control list standard is going to be basically matching on a certain source IP addresses. So what it is basically, in configuration, I need to match on the address I want to filter out. So access list, in my case, will be matching on, let's just say for the arguments, in 10.1.45.0/24. How do I do that in Cisco iOS? What follows this is a number or name. So actually name would be IP access list. If I use access list keyword, I have to go for number. Numbers 1 through 99 is a standard access control list. So if I say, let's just clear my terminal. Access list number 1 will be standard ACL matching on a source IP address. So what follows is a source IP address. So it's saying deny or permit. Now, in this context, I want to deny that network from entering their routing table. So I will say deny statement. What do I want to deny? I want to deny 10.1.45.0. And this is the gotcha. In access control list in Cisco iOS, we don't have mask. So it's not going to be 255.255.255.0 matching on the network 10.1.45. the subnet needs to be matched on using wildcard mask, which is the inverted mask. So when we had ones in the binary, now we have zeros. So first is 8 ones, now we convert them into 8 zeros. So 0 is going to be matching on this number 10. Full number 10. What follows, we need to match on number 1, so that's the second byte here. We need to match on this third byte here, 45. And we don't care what is going to be the last byte. So we don't care, we use ones, so that's going to be in decimal, all ones here. And again, refresher of that is going to be placed in the description box. So that's my 4 bytes, and we match only on 10 here, on 1 here, we match with zeros, and we match all zeros here on 45, and we ignore, or we don't care about the last byte, and that's going to be ones in the wildcard mask. And that's it. However, access control list starts its operation from top to bottom, from the first entry to the last entry, and if the last entry is hit, there's an implicit, not written, deny everything else. So at the moment I'm denying 10.1.45.0 subnet and then denying everything else. That's not what I want to do. So I need to create a second access list statement, access list number, the same number, and permit all the rest. Now all the rest would be just any address. So this is the syntax, which can be summarized to one keyword. So we don't care about the address, and we don't check any binary digits in those bytes with all ones. There's an equivalent for that called any. And that's my access control list that matches and denies the 10.145 from entering the routing table. Obviously, it hasn't been applied yet. It doesn't do anything at this point. I still have to show IP route 10.145.0 in my routing table. But with this access control list, I can now do that inside the router OSPF1 and the distribute list command. So I'm going to say distribute list, and the keyword is basically number 1, because that's my access control list here, number 1, denies that and permits everything else. And I need to say inbound. So from entering, from coming into the routing table. If I hit enter, if I do show IP route 10. Actually, let's go for OSPF first. So 10.1.45 is gone. So if I go for specifically, do you know how to reach 45.0 in the routing table? No, I don't. Subnet is not in the table. Now, if I do show IP OSPF database, though, it's still there. It's still there, though. So we have this link state advertisement done by R5DR and in that network, because it has to be the same on all the routers within the area. It has to be synchronized. Now, obviously, if I remove that command, so let's say I did some maintenance and I want the router to learn that, and I would, for the argument's sake, also I would remove no access list, by the way. Number 1, do show IP route OSPF. The network, the subnet, is back in the routing table here and available for routing. So that's the first way of dealing with filtering within the area. There are 2 other ways of doing that, but that's going to be a subject of the next video.